So can everyone hear me?
Yes. Put it on.
Is this better?
Yeah.
Okay. All right, let's check it out. Last one.
Woohoo!
Woohoo!
Yeah, let's do it.
We almost made it. Okay, we have seen data lakes. We have seen analytics, dashboard, call to action. We have seen cybersecurity. We have seen how to lead the teams. Okay, there's a lot of technology here. But how these freaking technologies communicate with each other. So we're gonna look at queues, notifications, or events. What is the right AWS tool to choose for your project needs? Oh, before we dive, what is AWS? Anyone? What's AWS?
Amazon
Web service.
Okay, yes, Amazon. It starts with that.
Web Service.
Yes, it's Amazon Web Services. And of course, as we say, answer to everything is cloud. But that always says, everything is cloud. It is cloud. AWS stands for Amazon Web Services. It's a cloud computing platform that offers over 200 fully featured data centers, which run across for infrastructure as a service, platform as a service, software as a service, and also provides a lot of integrated tools for application integrations. This is me thinking, yay, I got it. I know a lot about cloud. I'm ready to be the rock star developer. Yes. And then I gave a thought to look at multiple messaging and event services, which are provided by AWS. I'll get to why I'm being specific on AWS in a minute. And I thought, okay, simple queue services, simple notification services, Event Bridge, are messaging and event services of AWS to use for application integration. Yeah, I know it. I'm an engineer. So what? So what? But the real question in my mind was, when I look all of these three together, why does my team always hit a roadblock on when to use what? In what use cases? Anyone has faced an issue about, in general, which service to use when in a design when you're trying to create a new project?
Yep.
This is because these three, they look similar, they even sound similar, but they are actually intended for very different purposes. Okay. And that's when I knew, Jesus, there's a lot more to cloud. Okay, so let's dive a little deeper into what is our cloudy agenda today. We're gonna look into some back to basics into application integration. We'll go to each of the services at a time, look at one of each one example, do kind of like a bake-off with which one to pick, and we'll definitely have room for Q&A. Hold on. This lady here, little short, wearing some heels, tells me so much about cloud engineering, AWS. Who the hell is she? My name is Pallavi Varandani. I'm a computer engineer. I have a master's in management of technology. I have over 5 years of experience working as a support engineer. And currently I work for Amazon, so that's why it's AWS. I have led advanced troubleshooting and automation processes for Amazon Ads product. I have designed efficient boosting tools and services using AWS as my cloud suite. So let's dive right in. Application integration. What is application integration? Come on, just stop speaking up. What do you know?
tools work together.
Yeah,
Okay,
helping tool applications communicate with each other.
applications communicate with each other. Yes, it's a process of facilitating communication, interaction between two applications in a streamless manner. And especially this is used in the events of service as architectures. AWS application suites provide services to do these processes. And there are multiple benefits of application integration. And one of the key ones is it decouples your application. It keeps them separate. One hand doesn't know what the other is doing, but they can still communicate with each other at the same time. And additionally, it allows development at an agile pace, and you no longer need to write custom code, especially in AWS world. You don't need to write custom code to integrate two applications together. You can just do it based on probably just CLI commands, or but by just using the console UI. All right, so let's get into one specific example. Imagine you have an order service. I'm going to take e-commerce as an example because it's an Amazon suite, Amazon product, it's an e-commerce store. And we're going to follow a similar example throughout the presentation. So I have an order service, a person placed the order, customer management system got updated with their customer information, what the order was, inventory system removed that particular product from the stock, -1, accounting processed the payment, and shipping team ships the product. Very basic. I mean, real world is way complicated than this, but how this happens, and this is where the application integration plays a critical role. All these applications are integrated with each other, and that's where the real magic happens. Okay. Now, why do we need to integrate applications? Without application integration, these updates would have to be entered manually into each system. Very time-consuming process. Do we have time for that?
No way. No way.
Do we have time for errors?
No way.
It's an error-prone process. And with integrated applications, data flows automatically between systems, increasing efficiency, reducing errors, and providing real-time updates. This not only saves time, but also enhances the customer experience because it's seamless, it's consistent, and it's quick for the customer. There was a time you used to sit on the laptop when Amazon used to sell books, the book will load with the first 1994 website because it took time. And how did the speed increase is different decoupled application in the backend, which communicate with each other at a faster rate than just a web page processing things. So it's a strategic approach to streamlining operations. How do they communicate? And that's what we're going to be talking here. That's the crux. Before that, don't most of the modern applications and businesses actually already do all of these things? Why are we talking about it? And hence the question is how, not the why. How do they work? Depending on your use case, these applications can communicate using queues, events, messages, services, what I either call a fire and a forget mechanism. You fire the change and forget about it, or a batch process. Unlike APIs, which is more of a request-reply paradigm. I'm not going to get into the weeds of the APIs here, because our scope is around queues, events, and messages. But yes, APIs has its own application in the enterprise world. Let's dive in. Our first candidate, which is simple queue services. I call it the juggler. I'll get to it why I'm calling it a juggler. So it is one of the oldest queue services by Amazon. It was launched in 2006. But it has a very robust foundation. It encourages decoupling behavior with asynchronous message flows. It is a reliable asynchronous message-based communication service for enterprise scale service-oriented organizations. That's a lot of words, which nobody can process together. Okay, I just threw a lot of tongue twisters here. Let's break it down. Imagine a world where applications chat not by knocking at each other's door, but leaving messages in the mailbox. That's batch processing. That's SQS for you. A reliable postman for asynchronous communication of enterprise applications. It changed the game by allowing services to communicate without tightly coupling, which I just mentioned. It can scale at a very high volume. Think of it as it's an athlete who can run sprints, but at the same time it's an athlete, multi-talented athlete who can run marathons. Depends on the type of the data you provided. It guarantees high availability because it's part of cloud, of course. You don't have to maintain the underlying architecture, and you don't need to write as much as integration complex codes. It is cost effective with free API calls. I've used the word APIs because underlying it does use some API calls, but it's more for batched processing. When I say cost effective, it allows 1 million calls just for the free tier. And in the enterprise world, it might be very little, but if you're really starting a small scale business, it might just be fine for you to get started at least. It suits variety of contexts, which can go from e-commerce to, as we said, analytics team. You have a big analytics team in your company. They're processing data. That's the rate at which they're processing data. They cannot afford to process data at streaming level at times, which is present. So, yeah, absolutely. They are the other ones which are processing data. IoT, the Internet of Things devices, they're generating data at such a faster rate, which is difficult to process in the back end at the same rate at which it's being generated. You need something in between for it to slow down a bit and save the company some money. Because at the end of the day, we're all in the world of money, so we all are making money off of it. Okay, so let's look at some core concepts. I've been uttering the word queue a lot here. Queues, messages, polling. What is a queue? Okay.
So turn.
Yeah.
It's a way to turn.
Yeah, I mean, example. I'm gonna say another basic human world example. You're standing in a line for watching a movie. You're standing in a queue. That's exactly what it is. There are messages. We'll get to what is messages. There are messages which are standing in the queue to get delivered to the end location. This is the source, this is the end. These messages can be delivered in any randomized fashion or in the fashion which you want it to be delivered. Who's familiar with FIFO? Okay. First in, first out can be applied here. It is not a default behavior of SQS, but you can set it up. You can have it first in, first out, or you can have it let it be in a random fashion, but once you set it up in the system, if it's a first in, first out, you cannot change it. Or if you don't set it, you cannot set it back to first in, first out. You have to create a new SQS for that. So, in this case, that's why I call it the juggler, because it can juggle between sending random messages versus even first in, first out the way we want to set it. Now, what are messages? What are messages?
Piece of information.
Piece of information. Yes.
Yeah, piece of
It can be any JSON blob, any text messages, any files, any videos, which need to be sent from the source to the destination. So we call the source as the publisher and the end location as a consumer. Now, how does this end consumer obtains that data? They pull the data from the queue. They have to request it from the queue into their system. Let's see an example. Here, the customer made an API call to the order service. This is the front end. Front end will use API calls because it will respond to the customer with the information which is needed. This order service will throw the information along with this processing. It will throw the same customer's processed order, the packaged message. This customer bought a book, say, The Dream Machine. We're reading the book Dream Machine with Software Women in Technology right now. Consider we bought the book, and the order is in the pending state. The amount of the book is $20, and the shipping address is X, billing address is Y. This is the content. All those information has been packaged into an envelope message, which has been put into the queue, goes straight to a analytics service, but analytics service is actually pulling the message from that queue. So that goes to the analytics team of, say, Amazon. Oh, this person is buying the Dream Machine book and has been probably buying books every month. That means this person is a reader. Let me use this data to market more books to that person who's really interested in technological books. So that's how the message from order service has reached to the analytics service of that company. Now, this would have made a direct call. Why do you need the SQS? Imagine this is a direct call, the order service would need to know this is just one service. There can be hundreds of services. They'll have to be configured for each and every service. Any change on each and every receiving service, the order service will have to change its things. It's tightly coupled. Do you want to, every time you make a change to one service, you want to change the other service too? Do you want to be independent of changing the services? That's where SQS comes in pictures. Of course, if you make changes to the SQS, the services will have to be updated, but the core service updates for order service doesn't matter what is at the receiving end. All it knows is I need to dump the message in the queue. That's it. Whatever is going to happen will happen later on. All right. So, jumping to our next one, SNS. We're going to go a little bit deeper in this because we're going to run eventually some comparison between SQS and SNS. SNS is called Simple Notification Service. I call it the crier of the cloud tower. Because it's notification. It buzzes our phones all the time. It was one of the other virtual services of Amazon around the same time as SQS, Simple Queue Services, started. And it has something called fan out. Think of it, you're sending a broadcast message. If you have a kid's birthday party, you're sending a broadcast message to invite the party. You're fanning out the messages to hundreds of people. That's what simple notification services. But you would say, I can do that from my phone. Why do I need this? It has two flavors, application to person and application to application. One application can cry out messages to another application and so on and so forth. There are a variety of subscribers. We'll get to what is subscribers. It's just another term for consumer. I'm getting a little ahead of myself because I'm really excited. Variety of the subscribers could be emails, HTTP, SQS, even SMSs. SMSs is one of the subscribers. Yes, it's durable, it's managed because of its feature of sitting on a cloud platform. And you don't have, it says no message lost. They tag it as no message lost, but I want to correct that a little bit here. And I kept that up intentionally because that's what the documentation says. If a message is sitting over there for days, yes, it will get lost. There's a way how you can handle that, like not to let a message sit with them for days. There is a way. We'll get to that one too. So yes, it's durable, managed, and it has two flavors, which is app to person and application to application. Okay. Let's go forward. Let's look at some of the core concepts around this. They have something called topic. Now, think of SNS topic as a meeting square of the old town. Unlike the queues we discussed earlier, topics are not just storage, they are dynamic dispatching hubs. Topics, they're designed with a theme in mind. Say your theme is promotions. You want to send out your company's promotions. You're giving 50% off on eyeshadows in your retail store. And whoever person is subscribing or is your customer, you want to send out the promotion. So promotion is your topic. Now, in this case, the order receives a order submission that it has been canceled. When an order gets canceled, there's a lot of churns happen. We cancel it with a button on our phone on a retail site. Does anybody know what happens behind the scenes?
Yeah, it's crazy.
It's a crazy. It's like, imagine in a sci-fi movie when you see those gears churning around everywhere. That's what happens pretty much. It's just in the form of zeros and ones, which is the code, not the gears for sure. So when an order gets canceled, the person announces to the topic. How does it announce? It doesn't send the original copy of the message. It duplicates it. It never sends the original message. It'll always duplicate it as a copy into the top. And that copy is announced to every possible system in that enterprise product that this order was canceled. It'll retain the original. I'm going to repeat that because this is a key that system failures can be prevented. Creating copy. Yes, it's a redundant data, you're creating a copy. But it can help with recovery in the event of system failures. Okay, messages, yes, they are the same JSON blobs. Our messages are going to be the same across all the three message event buses which we're talking about, because message is the data, like the data which Dijana spoke about, that those data are stored in databases and which are actually living behind all of these things. But how that data is reaching to that database, this is what that process is at an enterprise level. So these are those datas in different formats. And I like to use the term as JSON files because I work with them a lot. Last one is publish or subscribe. Now, in the SQS world, there is called polling. They poll the message. But the receiving services actually own that SQS in the previous one. In this case, SNS is not owned by these services. They subscribe. It's like a newsletter. You subscribe to that newsletter to receive updates from that newsletter. So these are all subscribers. They are not polling, they're subscribing. All right, so we're gonna jump into our first example, which is application to person model. We actually briefly spoke about it. You have a promotion in your store on eyeshadows. I think I said eyeshadows. We'll just switch it. You run a physical store, but you also have a retail website. And you sell all the makeup products. Eyeshadows are at 50% sale. When your people come to shop in your store, they are giving you their phone numbers and they are signing up for your store. You have lists of all your customers. You want to send them the promotion to their device. SNS is your friend. If your product is using the entire AWS suite. I'm not going to argue on there are other products in the market which can do all of these things. Yes, for sure they can. However, in the world of AWS, this is one of the ways of handling it. One thing different here is, say I want to send a message to a targeted pool. Say I want to send a specific custom message to this customer for. I can customize it too for that customer for. And SNS allows me to set that as a separate application to send the messages periodically to that customer. So yes, it's a one-to-many fan-out model. All right, example number 2. Okay, if you see here, it's similar to SQS. As I said, like these look very similar. Very similar. I'm not gonna repeat it, but just think about the same logic which we spoke about. Person placed the order, went to order service. The topic in this case, these people are subscribed, and the topic will broadcast the messages to them. However, if you see here, we have a new friend here.
USQS. I'm so mad at
Is it a new friend that we just spoke about?
Yeah.
So if you notice, we have SQS here. SNS can broadcast messages to SQS. It's a system. They work together. They can work independently, but they don't compete with each other. So technically, this is a recommended model. Let your main service order, which is receiving, send the message to SNS, and SNS will broadcast that message to each SQS, which connects to an application. So that is a recommendation. Of course, you can do all the other ways, but why? Think, why? Why do we do that? And we're just trying to compare these two, but I just made them siblings. Before we see that, like why we're doing SNS to SQS structure is recommended. Can't this problem be just solved directly by SQS? Why are we even using SNS in the first place? Yes, it's broadcasting messages to the applications, but why are we using it? Think about it. Each of these things This was a single SQS. They keep polling the message. Once they poll the message, there'll be one winner because there's only a single message. There's no copy of messages. One will win, the other services won't get it. So, for example, analytics service will win. The accounting service and the dashboard service never got that message. So SQS, single SQS is not a problem. It's not a solution for the things. Okay, I'll set up multiple SQSs. However, isn't that too much overload on order service? Think about it. 3 pipes. I'm just talking about 3 pipes, but there are hundreds of pipes. There will be like hundreds of pipes connecting to single order service. Isn't it an extra load on order service? It is fine because SQS is owned by each of these individual ones. They can manage their own SQSs, that's not a problem. But why are we putting the load on order service? Doesn't that create an overhead and too much maintenance? So, hence it's recommended that order service puts the copy of the message to SNS. SNS broadcasts the message to each SQS which is subscribed to the SNS, and then those each services read the message at their own pace from the SQS. So SNS requires fast. It has to be, it's a streaming data, streaming notification. If you receive directly messages, if these services directly receive from this, they have to process it immediately. They cannot wait. They have to run at the speed of SNS. They cannot set their own pace. SQS is a temporary holding pool. It'll hold the message for each of those services. All right, coming to our last one, EventBridge. It's actually a new player in the town. And it has a big impact. Thinks it has a big impact. It is my okay-ish favorite, but not the most favorite. It connects apps with events. Events are really specific. So we saw the message is like a proper whole data, but event is like a one particular data point. Order status can be an event. Pending, delivered, shipped. That's an event. So this runs with events. Again, it comes in 3 flavors actually. It has something called event buses, it has pipes, and it has scheduler. I see event buses as one-to-many again. It's very similar to SNS. EventBridge is very similar to SNS. Event bus is a one-to-many, but I see the pipes as many-to-many. So it will allow you to do a many-to-many. I don't prefer many-to-many because it can create a lot of failure points, but it is possible. Pipes, I see it's a direct communication with multiple applications together. Scheduler is something which is different than SNS and SQS. To do scheduling with SNS and SQS, you need another service, which is CloudWatch and a couple of more services. In this case, there is a scheduler with it in both. So I'm going to dive a little bit on the scheduler side, because it's one of the unique areas of EventBridge, and it allows you to submit patterns. So it allows 2 types of occurrences, which is one-time schedule versus a recurrence schedule. One-time schedule would be you have a product launch on, say, 31st of March. And you want that EventBridge event to trigger on 31st of March at this X particular date. So that's what you would use one time, but you don't want it to trigger any more than that. Recurring has two types of scheduling. One is form-based, where you can actually give an expression to it. and the other is rate based. So you can set the rate value for run at every 1 minute or every 1 hour. So you can set that up. And what's really interesting is flexible window time. If you choose a flexible time window, scheduler will invoke in those X minutes. Say, I want it to it run within the 15 minutes of the time window I gave. So it gives you the flexibility of being flexible. That sounds like too rhyming, but yeah, it gives you the flexibility. Next is it allows you to select actual time zones. So you don't need to do the mental calculations yourself. Okay, I need this thing to trigger in EU region at this particular local time. Let me see what it is in NA because I'm sitting in US to schedule an event which is supposed to be triggered in Europe. I can just change the time and set that. I don't need to think. So, again, we're gonna go with the core concepts. We just spoke about messages, which is pretty much similar. Events can be order statuses, as I said. It could be shipping, pending, delivered, returned, canceled, rules. Okay, they are basically some intelligent directions which the event bridge has. When a particular data point is received, or that event is received as part of the data point is part of the event. If you want to transform that data or filter that data, I only want the statuses which are delivered, not canceled versus, I just want the delivered data. I don't want all the data. So that's the rule. That's the rule which we can set in the event bridge. And speaking of target, what is target? We just spoke.
The application that is receiving.
Yes, exactly. It's just they're using different terminologies because each product has its own terminology. So we gotta be a little fancy with our words. We gotta repeat words all the time.
Product.
What?
You can blame product for that.
I know, I'm gonna blame product for that for sure. Hey, guess what? I don't work in AWS. I use AWS. Just kidding. So yes, they put another word for that, which is your target. But before I dive into the actual example, I'm going to share one of my real life example, what I did with EventBridge. Actually, it was the first Southfield of Women in Technology event, the symposium. I was right here at Barker's house in Florida. My manager messages me, hey, I want a summary of what are in supports, there are tickets, you do ticket work too, along with development and automation and troubleshooting. I want to see which are the tickets today at an X given day are elapsing their TTR goal. And every day morning I come, I want that thing front in my face. I don't want to open my computer. I don't care. I just don't want to open my computer. Like, I want to see it even if I'm sitting in my bed. Okay, that's a problem. Okay, he wants that. And I didn't question him. Initially, I was thinking I should question him. What is your problem? Why are you lazy? Go get your computer and figure it out. Look at dashboards. I was like, okay, this is an interesting problem to solve. So does your company use Slack or Teams? Yeah. We use Slack. I was like, okay, the easiest thing which is on his phone is Slack. I'm going to reverse engineer from there. He can probably get notifications on the Slack. But how can I get the notifications on Slack? I think within those 2 days, I wrote a whole freaking Lambda function. It was fast because it wasn't the overhead for me because I could write it. I wrote a whole Lambda function which triggers till today. It's been 2 years. Product is still running. Every day morning at 9 a.m., it sends a notification to the whole team, not just him, the whole team on Slack that these are X of your tickets which are at risk. So you can be proactive in figuring out that that becomes your day's priority to resolve versus looking at something which is a lower priority for the day. You can help the team to prioritize things, and at the same time, a manager is notified. And he's happy, and now he's not part of the team anymore. He moved to my sister team, and I keep arguing with him all the time. All right, let's get to the real example. Another one. The same or slide example, each of the messages are drawn from this bus, the message bus, same concept going to all of them. Now, what makes it different? Third-party integration. You can actually integrate that's why I told you the story, because I'm connecting Slack. EventBridge allows third-party integration. I can argue that they could have just ended up putting it as a feature in SNS rather than creating a whole different product, but that's, again, as Renata and I agree, it's a product problem. So, yeah. I will dive right actually into this, the bake-off. SQS is a reliable 1:1 asynchronous communication between microservices. And it's a temporary holding pool which allows you to process things at the rate which you desire for your application. It can support ordered message, which is FIFA processing, while SNS is more of a fan-out process. It has high throughput because it's just doing streaming data and broadcasting. And it can have like millions of subscribers. You don't need to just stop at few hundreds or something. This also has one-to-many, but I think there's one limitation on this, and it might have just updated. One rule, I think it was like one rule can have only 5 applications or something like that. So there's a limit on the rule side. So that's why I say like it's one-to-many, but actually the key is it has a scheduler and the third-party integration. That makes it stand out. So when your product needs a third-party integration, EventBridge might be just your pick candidate. And SNS is when you want a broadcasted message, while Q is when you want to work at your own pace. Some resources are, you can definitely go to the documentation of each of those, SQS, SNS, and EventBridge. AWS has its own YouTube channel where they actually have a lot of tutorials, which I find it's really more than enough. It's actually thanks to all the developer advocates who make them. So yes, I'm actually, by every presentation I write each blog. So I'm coming up with my blog should be here by end of this month. So you can go to my website and read it, which will be more in technical details with some examples and also some GitHub links on code samples. So you can check my website out, and you can connect with me on LinkedIn to get it in the slide deck. And if you have any questions or want to work on custom solutions for your project. And I open the floor for some questions.
So then, does it have to be a modern application for that to, no? So it could be a monolithic application in Silver?
You can work with monolithic applications too. Yeah.
Oh, cool.
Yeah.
Seems like a lot of times you were combining. It's not like an either or necessarily.
No. You're actually combining different services to take the best of all the worlds.
Any questions?
All right. Game is over. You can continue restart the exit.
I love that.